We will now solve this indefinite integral, which is integral of 3x cube over under the root of 16 plus 25 x squared dx. So for this, we are going to use the trigonometric substitution, and we are already given this side A equals 5x, and we have to determine the side B as well as side C, and also fill in the blanks for the other three expression. So first, let's determine the side B and side C. For this, I'm going to consider this expression, that is under the root of 16 plus 25 x squared equals c. So which means when we apply the Pythagorean theorem to this right triangle, we get a squared plus b squared equals c squared. And we already know that a equal to 5x, so therefore this becomes 5x quantity squared plus b squared equals c is 16 plus 25x squared under the root quantity square. We can determine b from this equation. So therefore this becomes 25x squared plus b squared equals the square of under the root will become only this expression without the square root. So we will get 16 plus 25x squared. We subtract 25x squared both sides, so therefore these two get cancelled. And finally, we get the value of b squared equals 16. So this implies b has to be 4. So we found the value of b equals 4. We can write down here this b equal 4, and c, the expression for c is 16 plus 25x squared under the root. So we write down the same on this triangle. I'm going to clear this up, and I'm going to mark b as 4. So this side length is 4, and this side length the c is 16 plus 25x squared under the root. Let's determine the other expression, that is 5x over 4. For this, we look at this triangle. This is a right triangle, and here we can apply the trigonometric ratio, that is 5x over 4. Basically, this equals a over b, and this equals opposite side over adjacent side. And in terms of trigonometric ratio, this is an expression for tangent of q. That is, only tangent of q is a over b, which is 5x over 4. So you can say that 5x over 4 equals tangent of q. And we have to determine the next two expression. So let's utilize this expression, that is 5 by 4x equals tangent of q. Now let's take differentials on both sides. When we do that, we get 5 fourth. The differential of x is dx, and here also we have to take the differential of tangent of q with respect to q. So finding the derivative of tan q, we get secant squared q times of dq. So therefore we can now say that this expression, that is 5 fourth dx equals secant squared q dq, which I'm going to write down here. So this is equivalent to secant squared q times dq. And finally, we find the expression under the root of 16 plus 25 x squared over 4. For this, we can utilize this triangle. So basically, this expression, that is 16 plus 25 x squared over 4, looking at this triangle, we see that it is c over b. This equals 16 plus 25 x squared under the root over b is 4. And in terms of trigonometric ratio, this is basically secant of q. This is equals secant of q, because secant q is a hypotenuse over adjacent side, and c is the hypotenuse and b is the adjacent side to angle q. So therefore we say that this expression equals secant q. I'm going to write down it over here. We now rewrite this given integral in terms of the trigonometric ratios, which we found using this triangle. So for that, I'm going to rewrite this expression, that is 5 fourth of x. From this, I'm going to solve for x. So x equals, I multiply both sides by 4 fifth. When I do that, I get x equals 4 fifth of tan cube. And here also in this expression, I'm going to solve for dx. So dx equals, I have to multiply by 4 and divide by 5. So when I do that, I get 4 fifth of secant squared cube dq. And here as well, I'm going to solve only for this under the root of 16 plus 25 x squared. So therefore, this becomes 4 times of secant cube. And this means we can utilize all these expressions, replace those quantities into this given integral and convert that everything in terms of trigonometric ratios. So let's do that. Let me copy the given integral, which is 3x cube over 16 plus 25 x squared under the root dx. So this is equivalent to, I factor out the 3, and in place of x, I'm going to replace this as 4 fifth of tangent of q. So therefore, this becomes 4 fifth of tangent of q, quantity q, over this expression 16 plus 25 x squared. I can write it as 4 secant cube. So this becomes 4 times of secant cube. And then times of this dx can be replaced as this expression, that is 4 fifth of secant squared q times of dq. So we integrate this. Now let's simplify this, and this equals, first let me collect all the numbers. So I have 3 over here, so I put 3 here, and this 4 fifth is under the quantity cube. So this equals 4 fifth quantity cube, and we then have this another 4 fifth. So I put 4 fifth and divided by this 4, so I can write down this as 1 fourth. So I have collected all the numbers and put it in front of the integral, and inside the integral we will write the expressions. That is, this is tangent of q, quantity cube is tangent of q, that is tan cube q times of, this is secant squared q, the numerator, over in the denominator we have another secant cube, and then we have this dq. Let's simplify this expression. We see some cancellations. We can cancel this 4 with this 4, as well as the secant cube goes one time, that is secant power 1, or is just simply secant cube. And we will simplify this product. So this equals 3 times of 4 cube divided by 5 cube. 4 cube is 100 and, I'm sorry, it is 64. Divided by 5 cube is 125, and we then have 1 fifth. So this basically equals 3 times of 64 is 192, and 25 times of 5 is 625. So the product of these numbers is 192 over 625, which I write down here. This becomes 192 divided by 625. Integral of, we simplify this, that is, this is tangent of cube q times of secant q dq. So basically we have to integrate this expression inside the integral, that is tangent of cube q times of secant cube. I'm going to rewrite this expression so that we can find it easy to integrate. So let me first put the numbers as it is, that is 192 over 625, integral of this tangent of cube. I'm going to rewrite this as tangent squared q times of, we will have one tangent q, and that I'm going to combine this with the secant cube. So I rewrite as like this. This is perfectly correct, dq. And now we can replace this tangent of cube using the trigonometric identity, that is we have this Pythagorean identity, that is 1 plus tangent squared q. This equals secant squared q. So we can find an expression for tangent squared q when we subtract 1 from both sides. So this basically equals secant squared cube minus 1. This means we can replace this tangent squared q as secant squared q minus 1. So let me do that. So therefore this becomes 192 over 625 integral of secant squared q minus 1 times of, we have this expression, tangent of q secant q dq. And now I am going to use t substitution so that we can solve this integral in terms of the trigonometric ratios involving the angle q. So let's put secant q equals t. Now we take differentials on both sides. The differential or the derivative of secant cube is secant q tangent of q, and then we have this dq when we take the differential, and this differential of dt is just dt. So if you look at this integral, we can replace this expression, that is tangent of q secant q dq, as just dt. So this perfectly becomes as dt. And as we already made a substitution for secant q equals t, so this will become t squared minus 1. So finally, when we rewrite this given integral after we made this t substitution, this will become as 192 over 625 integral of t squared minus 1 times of dt. As you can see here clearly, it is t squared minus 1 times of dt. So let me write this. And now this is an easy integration which we can integrate. So this is going to be 192 over 625. The integral, we can use the power rule of integral, that is, suppose if you integrate x raised to the power of n, this equals x raised to the power of n plus 1 over n plus 1. So similarly, when we apply this formula, we get integral of t cube is t raised to the power of 2 plus 1, which is 3 over the same quantity, that is 3, and minus of integral of 1 dt is just t. So now we integrated this, and now we have to do the back substitution for t. So let's replace t as secant q, which we already did the substitution. So therefore this expression is going to become as 192 over 625 times of, we put this bracket, secant cube, because t is secant cube, quantity cube, over 3 minus of secant cube. Let's simplify this. So this equals 192 over 625 secant cube quantity cube. We can rewrite in a different form as like this: secant cube cube over 3 minus of secant cube. Now we have to do the back substitution for secant cube. For this, we will go back to the original expression. As you can see here, the secant cube is 16 plus 25x squared under the root over 4. So we can replace it as like that. So therefore this becomes 192 over 625 times of 16 plus 25x squared under the root over 4. This is quantity cube. I replace this for secant cube, and we also have that 3. So that is divided by 3. So I'm going to write it as multiplied by 1 over 3 minus. Now let me replace for another secant cube, that is this secant cube. So when I do that, I'll get 16 plus 25x squared under the root over 4. Let's simplify this. So first, let's simplify this quantity, that is under the root of 16 plus 25x squared over 4 quantity cube. So for that, I'm going to consider this 16 plus 25x squared as a. So that becomes under the root of a quantity cube. So this equals this root a has to be multiplied with itself 3 times. So therefore this becomes root a times of root a times of root a. And this root a times of root a is just a times of root a. So now we can replace this a as 16 plus 25x squared. So therefore we can rewrite the expression as 192 over 625. This is replaced as a times of root a. I'm replacing a by 16 plus 25x squared times of root a, which is 16 plus 25x squared under the root, and then divided by this 4 cube is 64 times of 3, and this equals 64 times of 3 is equivalent to 192. So let me replace this as 192 minus, we have this another expression, that is 16 plus 25x squared under the root over 4. So we can now see that we have a common factor, that is this expression is the common factor. We can factor it out of this big square bracket. So let me do that. So when we do that, we get 192 over 625 times of 16 plus 25x squared under the root. I'm just factoring out this, and when we do that, we will be left with 16 plus 25x squared over 192 minus, since we have factored this under the root expression, this will become 1/4. Now we just have to simplify this fraction. So for that we have to have a common denominator, which means we multiply and divide by this uh, to make it 192. This 4 has to be made as 192. So when we divide 192 by 4, we get 48. So this for this fraction, I'm going to multiply and divide by 48. So that 4 times of 48 will become 192, and we then have the common denominator. So let's simplify this. So this becomes, we have this quantities 192 over 625 times of 16 plus 25x square under the root, and this becomes 16 plus 25x square. After we multiply, this becomes 1 times of 48 is 48, so it becomes negative 48 divided by, we have this common denominator of 192. Now 16 minus 48 is negative 32. So therefore we also see that now everything is a product here, so we can cancel this 192. So this becomes 16 minus 48 is negative 32. So this could be written as 16 plus 25x squared. I have written this expression times of, here we have 25x squared minus of 32 and divided by 625. So this is the final expression of the indefinite integral.